Okay, today is Thursday, November 19th. So let's go ahead and take a look at the table on my screen here. So your eyes are up here for right now. What you have in front of you, we'll get to that in a moment. But right now you're watching and you're participating along on the screen. So when you have a table like this, along the top we have the variable p. And for each of these columns, the variable changes in value. With this column, the value of the variable is 1. Here it's 2, here it's 3, 4, and 5. Okay, so what we need to do is we need to plug in the value of the variable and then evaluate the expression so that we get an answer. Okay, so number 1, we have 3, and the variable in this column is equal to to 1. Okay. So I'm going to put that 1 in parentheses to show that I need to multiply, because when 3 and p, or 3 and a number or a letter are next to each other, that means that we need to multiply. So we have 3 times 1 minus 1. Now there are two operations there. There's multiplication, 3 times 1, and then there's subtraction, minus 1. Caitlin, what will we do first, the multiplication or the subtraction? The multiplication, very good. So, everyone, what is 3 times 1? 3. Okay, bring down the minus 1. Now we can solve for the answer. 3 minus 1 is 2. Okay. So for that box, the answer is 2. Now in the next box, the value of p is now 2. So we have to substitute 2 in for p. So now we have 3 times 2 minus 1. Corbin, what will we do next?
We will
Multiplication or subtraction?
multiplication.
Okay, and 3 times 2 is?
6.
6. Bring down the minus 1 equals, everyone? 5. Good. Okay, can I have a volunteer help me write this expression substituting 3 in for p? Maya?
3 times 3 minus 1.
Very good. 3 times 3, again I'm using parentheses to show that, minus 1. Great job. Now we're going to multiply first. 3 times 3, class?
9.
9 minus 1, and what does that equal to?
8.
8, good. And now the value of p, because it's a variable, and variables can change their value. So now the value of p is 4. Kyle, can you help me set this up?
So 3 times 4 minus 1.
Good. Okay, do our multiplication. Everyone, 3 times 4 is
12.
12 minus 1.
11.
Good, 11. And lastly, we have p is the value of p is 5. Okay, let's go ahead. Raya, set it up for us.
3 times 5. 15.
Well, no, we have to finish writing the expression. What's it? No. Minus 1.
Oh, minus 1.
Okay, in our next line, we multiply. Everyone, 3 times 5 is
15.
15 minus 1, and the answer is
14.
14. That's right. So using the value of the variable and substituting it in and then solving the problem. Good job. Okay, another thing I want to review that we did on, let's see, Monday and Tuesday was identifying the terms, coefficients, and constants of the expression. So our first expression is 5h plus 9. Let's go ahead and box up our terms. I'm going to draw a box around them. What are the terms in 5h plus 9? Maya? 5h, good, and 9. Remember, the terms are separated by operations. Could be addition, could be subtraction, multiplication. Okay, so our terms are 5h, comma, 9. We're listing them, and when we make a list, we use commas. Okay. Now, our coefficients, or coefficient, there could be 1, there could be 2. Okay, coefficient. Now, if you have your notes from the other day, 3.1, it told you what the coefficients are. Okay, Maya? Okay, the coefficient is, that's right, it's 5. The coefficient is the letter that comes before, I'm sorry, the number that comes before a variable, that comes before the letter. So 5 is the coefficient. And then lastly, we have the constant. What is the constant here? Kyle? 9, right. The constant does not change. And it doesn't change because there's no variable next to it. Okay? The coefficient 5, that is the numerical part of a term where there's a variable, so it comes before, and constant remains the same. Did I use the analogy of the waitress the other day, earning money using tips?
Yeah, but it had the pen was on the board.
What's that?
The pen was on the board, wasn't the board. It's like you couldn't see.
Oh, okay. Well, if you listen to the conversation, I said that, you know, a server, a waitress, or waiter, they work for a restaurant and they get a set amount of money each hour, okay? So I use the example, they get paid $3 an hour. So $3 would be the constant because that doesn't change. But what changes though from hour to hour is the amount of tips. So that was the variable. Connor?
Which sheet is this on?
This we're just going over together up here, not on any sheet, okay? So we're just reviewing how to find the coefficient terms and constants. Okay, so let's take a look at number 2. Let's box up those terms. What are the terms? Corbin and number 2. Remember, it's the parts. What are the parts of that problem? A squared, that's a part, that's a term. Good. 2, good. 7b, very good. So those are the terms. Now let me ask you this. I see a variable, a, without a number in front of it. What number isn't written, but it's there? What is it? A 1, that's right. Whenever a variable is by itself, there's a 1 in front of it. So those are our terms. Now, coefficients. What are the coefficients? Look at all the variables. Remember, the coefficient comes before the variable. Coefficient. What do you think, Maya? 1 and 7. Why is 2 not a coefficient? Because it doesn't have a variable. It is the constant. Okay? The constant does not have a variable. It's just a number that stands by itself.
Are we doing every single one or just the odd again?
Nope, all the problems. That's why I did 1 through 11 yesterday. And I said we would do 12 through 19 today. Again, if you missed yesterday, you can watch the video. And if you don't have time to watch the video today, I can download it to your iPad so you can watch it without internet. Okay? I know there's a way to do that, and I can do that for you. So if you don't think you'll have time to watch the video while you're in school and you know you can't watch it at home because you don't have internet, I can download the video to your iPad so you can watch it offline. So if anyone wants me to do that, I can do that during my, while you guys are at special. Okay? Okay, so let's go ahead and move along to our homework. 3.2, like I said, we're going to focus on 12 through 19 today. Okay. And if you missed yesterday's lesson, it is extremely important because we did go over quite a bit. So hopefully you can keep up with the remainder of this. And that's why it's so important to try to stay on top of things so that you don't get behind. Okay, so for number 12, for this section, and you are writing your answers, we're all doing this together, so you should be writing these down. If you started your homework yesterday, you're starting on number 12 right now. You'll have to back.
All the problems?
Yep, we're doing all of them. And I did 1 through 11. We did them all yesterday. So that's why you have to watch the video. Okay? And you want to do this because this homework assignment's worth 5 points. Does that make a big difference in your grade? It sure does. It sure does. So you don't want to lose 5 points because then you are losing 5 points from your homework. Okay? Okay, so 2 phrases for the expression. Yesterday, if I show you the top of the paper, these were all expressions. Okay? And I'm going to do a couple of these. So, because raise your hand if you didn't get 1 through 11 yesterday. I have a feeling that there's quite a few of you. Raise your hand if you didn't do 1 through 11. Kyle, did you do 1 through 11? Caitlin, did you? No. Did you, Maya?
Yes.
So you,
Did.
if you didn't, so put your hand down if you did. Okay, Connor, did you do 1 through 11 yesterday? What's that, Kyle?
I watch the video at Resource.
Yeah, at Resource. That's
watched half.
fine. But I'm gonna just go through a couple of these
What number?
because I think it's important for everyone to know, especially if you weren't on yesterday. So Maya and Connor, you can just bear with me for a second. You can help me teach this, right? Okay, so yesterday we wrote the phrase as an expression. 6 more than 4.
Is it 6 times 4?
Okay. Maya, do you remember what more than means? Addition, right? So in these expressions, we have to be looking for key words that tell us what operation to do. 6 more than 4. How would we write that as an expression? Maya? 6 plus 4. Okay, and that's all we write for number 1. So if you didn't get number 1 done yesterday, that's it. Write it down.
So do we have to put on the workbook?
Yes, you have to use the workbox. Sticking with that, because guess what? 12 through 19, you're going to need more space, and I want everything together. So number 1, yeah, 6 more than 4 is 6 plus 4. Because addition is commutative, it could also be 4 plus 6. Okay?
Apparently I don't have 7 or 11.
Okay, well, you'll definitely want to get those in there, right? Number 2, 7 less than 15.
15 minus 7.
Very good. And you know, Kyle, that's great because you got it in the right order. It says 7 less than 15. So you have to write it so the 15 comes first. 7 less than 15.
When you see a division problem,
Division is very important too, the order, that's right. Okay. I'm just going to go quickly, okay? 3 times the number x, because I don't think you guys are all going to have time to watch that video, so I'm a little concerned. 3 times. What operation?
multiplication.
Multiplication. So how do we write that as multiplication?
3 times 1x.
Okay.
Just do 3x.
3x. That shows 3 times x, right?
And then you 3 point x.
3 dot, yep, and that's another way to show it
And then 3 and then x with quotation.
with a parenthesis around it, okay? So this is 3 different ways to show 3 times x.
Pretty surprising. We have 3 different ways for 1 plus 3.
Mm-hmm. Okay, number 4. Okay, the quotient of a number m and 4. Now they call variables their letters, right? Here, this is an m, but in math we call variables numbers. So it's a little tricky because you're like, what? The quotient of a number m? It's a letter m, right? But in math it's considered a number. So the quotient, and what does quotient tell you to do? Divide, right? Quotient is the answer to a division problem. So we know we're going to need to divide the quotient of a number m and 4. Okay, so how do we write that as a division problem? M divided by 4. You can write it that way. Mrs. Wallace, that's a fraction. Okay, yeah, it looks like a fraction, but it's also division, right? When you have a number over another number, that means you divide it. Think about when you do mixed numbers and you turn them into improper fractions or all that. Okay, what's another way to write it? You can write it m divided by 4. Okay, so this is another way. M division symbol 4. Like I said, I'm going fast, so you need to keep up. Okay, number 5. The product of 8 and a number p. So the product of 8 8 and a number p. Product tells you to do what? What operation?
Multiply.
Multiply.
So it's 8p.
Okay. So it's 8 times p. 8p, we could write it that way.
8.
8 dot p, or 8 with p in parentheses. Okay? Okay. Number 6. Twice a number x. Okay, twice. Okay,
We
well,
multiply.
it doesn't say product, it doesn't say sum or
Well, I
total.
know.
Raya?
2 times x.
That's right, because when you twice something, think about it. When you twice something, you multiply it by 2. So 2x. 2x. Now think about all the different ways you could write it, right? 2x, 2 dot x, 2. Whoops, I was going to put a p there. Now, we had this conversation yesterday. Why can't I use the time sign?
That would make no sense.
Because what does it look like? The time sign looks like the variable, right?
Yeah.
In algebraic expressions, we don't use the x to multiply. We use
X off the x.
we use the dot, okay? And we use the dot because if you use that little x to multiply that time symbol, you might think it's the variable. It can get very confusing. So that's why that's not one of the options. Okay. Number 7. A number decreased by 10. Decreased. What do you think? Add, subtract, multiply, divide.
Subtract.
Decreased means to
10
subtract.
Y. No.
We need to get it in the right order. A number y decreased by 10. Y minus 10. With subtraction, you have to read very carefully to make sure you get it in the right order. Subtraction's not commutative. You can't just switch it around and get the same answer. Think about it. With addition, I can do 4 plus 3 and get 7, and 3 plus 4 and get 7. But if I did 4 minus 3 and 3 minus 4, would I get the same answer? No, and that's why
You get a negative number.
we get a negative.
Negative 1.
That's right, and we're not into negatives yet, and that's not commutative. That's not the same.
I like negative.
This is the same.
Negative is 1 after 0. 1 before 0.
I don't know what that is. Okay, 8. Let's keep going. 7 fewer than a number k. Fewer. Fewer also means less.
7 minus k.
We're subtracting. Fewer means
I'm so happy we don't have to solve these.
7 fewer than a number k. So it's k minus 7 because it's 7 fewer or less than k. Okay. Number 9.
So c plus 3.
The total of a number c and 3. So total, what operation?
Plus
Addition. Yep. If you total something up, think about it. If you total it up, sometimes you see total with multiplication, but this is the total of c, the number c and 3. So c plus 3. Number 10, we see the word difference. Maya, what does difference mean? Subtracting, that's right. The difference of 11 and a number d. So Kyle, what do you think the sentence expression will be? The difference of 11 and a number d. Subtraction, so 11 minus d. 11 minus d. Which takes us to 11. Now 11, there's a problem. We need to correct it and describe it. So the phrase is 12 less than a number x. And they wrote 12 minus x. But read it again. 12, I want everybody to think about it. 12 less than a number x. What do you think is wrong with that expression? Well, there's a 12 and there's an x, and it's less, so there's subtraction. So what could possibly be wrong? What do you think, Corbin?
It's saying that it should be 5
It should be x minus 12 because the wording says it's 12 less than a number x. If it said the difference of 12 and a number x, then that would be right. But it says 12 less than, so your x has to come first. So what's the description? What did they do wrong? How could we write that in words?
They flipped the numbers and they did it wrong.
They switched the numbers, they mixed up the numbers, they wrote the numbers backwards. Okay, that would all be a good description. So they switched the numbers. Okay, so we have 20 minutes now to get through 12 through 19. You're welcome. You're
Is
welcome.
this due today or
Wait, Miss Walker.
This was due tomorrow, but we're doing it all together. So
Technically, we wouldn't.
technically everybody should have it done today, right? Because we're doing it all together. Tomorrow I want everybody who can, please log in to the Google Meet. It's very, if you're able to, please do. It's very important. We're going to go over more of these types of problems. Monday and Tuesday next week. You guys will be here Tuesday.
Are you going to be posting videos? Are you going to be posting a video tomorrow?
For tomorrow, yeah, tomorrow we're going to do a review and we're going to do a Kahoot together.
Yes.
On Monday and it's going to be on this. On Monday and Tuesday, we're going to have a quiz on 3.1 and 3.2. So we're going to review that and prepare you for the quiz. You're going to have the quiz here at school. I'm not going to do another one where you're doing it at home. Because literally,
Well, I didn't do it on
it's taken me forever to get those tests back that you did last week, so.
I'm posted.
Raya?
Well, I don't have to post it, but I'm not going to be there for me.
Okay. Okay, guys, number 12. Write two phrases for the expression x plus 8. So we are given the expression, and now we have to write a phrase like this, using words. Okay? So we're doing the opposite of what we did before. Mrs. Thomas, we just went over most of the class, except for two weren't able to get on yesterday. So I couldn't go over the second half if they didn't know how to do the first half. So we just spent a few minutes on that. So I said we're going to have to work really hard to get through this second section.
You were so nice, Mrs. Wallace.
We just
Well, thank you. Thank you. Okay, so it's x plus 8.
X plus 8.
Ooh, I know what.
Think about some ways that we could say addition. What were some of the words? You can look back to the top part of your paper, okay? What were some of the words to show addition? Connor?
X plus 8x or 8 plus x.
Okay, well they're already giving us the expression. We have to use words. But
Oh,
right now, what are some words that signal us that we have to add?
x add.
What are some addition words? Keywords for addition.
Some.
If you're not sure, you can look at your keywords paper in your folder. Sum. S-U-M.
I have a subject.
Okay, hold on, hold that thought, Maya.
The number of x more than.
Okay, more than, I like that. More than.
Total.
Total, good.
Add.
We don't come right out and say add.
Addition.
Or addition. How about increased by? So let's do this one together. Okay. Maya, what was your thought there?
1, 6. No, wait. Sorry. The number of x more than 8.
Okay. How about 8 more than
The number.
a number x? 8 more than the number x. Okay, so that's one phrase. Write it down. 8 more than the number x. So that is a phrase we could use to describe this. So everybody should write this down. This is number 12. Number your box.
And it says write two phrases.
Yep. So we got another one that we need to do.
Add 8 and x.
Well, no, we can't just come out and say add it. You have to use.
Okay. Increase 8 and
There you
x.
go.
Okay.
Increase 8 by
So x increased by 8.
Yes.
Okay. How I'll entertain other phrases. 8, or x increased by 8. Raya, did you have one?
Yeah, the sum of the number x and 8.
Very good. The sum of the number,
Two's okay, okay? Just write two.
yeah, you only need 2, but I wanna,
Do you have two, Brian?
number x and 8. Good. Pick your favorite 2. Good job with those.
Good.
Okay, so let's go ahead and do number 13.
And this one, can we do 20 minus n? It
That-
says that. You're
that's the-
saying it.
That's the expression. We need to use a phrase.
Okay.
Words.
Connor.
Okay, so stop.
Keyword paper.
Yeah.
Not Connor.
I mean, sorry, Corda.
Okay, so subtraction. What are some key words for subtraction? You can look at the top part of your paper and look at some of the ones where there was minus. Hannah, what's a key word for subtraction? What's that? How about less than? Hannah, is less than a key word for subtraction? It sure is. So less than indicates subtraction. What else? Maya?
Subtractions.
Decrease. Decreased by. Decreased. Good. What's the number? The answer to a subtraction problem called? It's called the
Difference.
difference. That's right.
There you
The
go.
difference.
Now you got it for me.
Or the answer.
Okay. Well, also reduced by. Fewer than. Fewer than. Okay, so those are all some options there. So now we need to use.
Don't write those.
We need to have a sentence. Let's come up with a
So now you
phrase.
gotta write the sentence.
So it's 20 minus n. Let's come up with a phrase for that. Caitlin, let's give it a try. I'm going to start you off. 20.
Decreased by
Hey, Caitlin, your voice
what?
changed.
20 degrees.
Caitlin, choose one of those. 20. Okay. Decreased. Decreased by a number n. Okay, so that's one phrase.
I thought it was decreased by 8. Meant 20.
Need one more. Connor.
N less than, or no. N
20.
less than 20.
N less than 20.
20 less than n.
20 less than n.
Why can't we
Wait,
just say 20
no.
Wait,
minus
no,
n?
he
You
was
gotta
right.
keep that- yeah,
You were
he was
right.
right.
You were right, yeah. N less than 20. Because n less than 20. That's one of the ones you have to
Think backwards.
think backwards.
Why can't we just say 20 minus n?
Because that's the expression. We're
Because
writing
Connor,
a phrase.
Or Corbin, think about this. If you had 20 less than n, right? Let's say you have 20 less than 40. Can I take 20 or 40 away from 20?
What about
You're
40
gonna have
minus
negative
20?
numbers.
Right, and we're not doing negative numbers in 6th grade.
Why can't we just add
So you have to watch how you do the subtraction wording.
Oh, I
Addition's different.
addition? You could just say
It gets
add.
me every time, believe me.
Miss Wallace, all negative numbers are the actual answer with a negative.
We're not there yet, Rod. You're good. Keep that till about 7th, 8th grade, you're good.
Yep.
Okay.
Okay.
Alright,
Does
moving on.
anyone need this any longer? Okay. Let's move ahead to number 14. So the directions for the next section are write the phrase as an expression, then evaluate when x equals 2 and y equals 10. Okay, so they're giving us a phrase, we need to write it as a problem, and then we need to solve it. Okay, number 14. 12 more than the product of 5 and a number x. Guess what? There's more than one operation in these problems. So let's go ahead and identify what operations we need to use. 12 more than.
Okay.
More than is what, Kyle? Did you say addition?
Yeah.
Okay. So more than means to add. 12 more than the product of 5 and a number x. Product. What operation? Raya?
There's parentheses around 5 times
What operation?
multiplication.
Multiplication. That's right. So So we're gonna have addition and multiplication in this sentence. So I like how you're thinking ahead to how you wanna write it down. Okay, so we have 12 more than the product of 5 and a number x. So what do we do first? Do we, well,
Wait, do I have to find the answer?
Yeah, you have to find out.
yes, eventually. So first we have to write down the expression. So let's write the expression. 12 more than, so 12 plus the product of 5 and a number x. So they're saying to multiply 5 and x. How do we write 5 times x as a multiplication?
5 right next to x.
Maya?
5 times.
5 dot x or 5x. Yep, 5 dot x would be acceptable too. Also, if you wrote your problem as 5x plus 12 because it's 12 more than that, that would be acceptable. I think this is okay too, right? Because it's commutative, so yeah. Okay, so let's go ahead and now we need to solve because x equals 2 and y equals 10. So we're treating this as an expression. So we're going to use the funnel, do order of operations, and any work that we need to do, we're going to do outside of that area. Okay, so let's go ahead and plug in our variable. What's the value of x? It is 2, right? So let's rewrite our problem. 12 plus 5 times 2. Plugging in that 2 where we see x. Now we need to evaluate the expression. Are we going to add or multiply first? Multiply. Okay, what's 5 times 2? 10, right? So we're left with 12 plus 10. And 12 plus 10 equals, that's right, 22. Okay.
Right, you have all that down? You need all the work.
Yep. Got it down, Connor? Got this written down? Okay, we're doing this together. I had someone in the last class just sit there and they missed like the first 5 problems and now they're gonna have to go back and do it. And they have the opportunity. Okay, number 15, the quotient of a number x and the sum of 3 and 7. So let's identify our operations. Quotient. What do you think, Caitlin? What's quotient tell us to do? No? No? You need to get out your keyword paper. If you don't know what these words are signaling, you need to have that keyword paper out in front of you, okay? Otherwise you're gonna do the wrong stuff. Maya? Divide. Quotient means divide. It's the answer to a division problem. So we have dividing and, okay, sum. What's sum mean? Add, that's right. Okay, so the quotient of a number x and the sum of 3 and 7. So the quotient of a number x. So x divided by the sum of 3 and 7. So what will we have in the bottom? The sum of 3 and 7 is 3 plus 7. So the quotient of a number x and the sum of 3 plus 7, or 3 and 7. So now let's go ahead and evaluate the expression. What is the value of x?
2.
2 over 3 plus 7. Okay, so in our next step, we're going to add our 3 plus 7. So 2 over, what's 3 plus 7?
10
10.
is equal to,
Can we leave it as 2/10 or can that be simplified?
it can be simplified to 5.
Okay, it can be simplified. What number will go into both 2 and 10? Connor? 2. Is that what you're going to say, Kyle? Yeah. 2. So we're going to divide both of those by 2. The numerator and the denominator. So when we divide both of those by 2, 2 divided by 2 equals 1. 10 divided by 2 equals 5. So the answer is 1/5. That is correct. Okay. I'm gonna leave that up for Corbin, that's quite a bit. Number 16. Again, we're looking at those keywords. 17 less than the quotient of 200 and a number y. Now I know like this might seem overwhelming, right? Like you read that and you're like, oh my gosh, how am I gonna make a math problem out of that expression? You really need to do step by step and look at the keywords. Okay, less than. What's less than mean, Kyle? Subtract. Okay. Quotient. What does quotient mean? Divide. Okay. So now we have 17, 200, and y. So I know that those are the variables and the coefficients and terms that I need to be working with to come up with my problem. So number 16, I'm going to read it closely. 17 less than. Okay, so I'm going to subtract 17 at the end from the quotient of 200 and a number y. So quotient of 200, whoa, 200, that's fun. 200 and a number y, how will we write that?
Well, you can write with your finger on the smartboard.
Yeah.
Just look at the
Okay, so the quotient of 200, so it's telling you that you need to find the answer of 200 and a number y. And then it says 17 less than the quotient of 200 and a number y. Maya? You certainly could put a 1 in front of the y. It wouldn't change the value of it. I think that we want to get into the practice of thinking that there's a number 1 because as you do more complicated math, that number 1 is important. I look at some of that high school math and woo! So yeah. Okay, so let's go ahead and start to evaluate the expression. What's the value of y? 10. So in our next step, we have 200 divided by 10 minus 17. So we have division. This is division. And we have subtraction. What do we do first? Division or subtraction according to order of operations? Division. So 200 divided by 10.
10. I'm at 20.
20, that's right. If you need to do the work, right? 200 divided by 10, right, is 20. So here we have 200 divided by 10. The quotient of 200 divided by y, which is 200 divided by 10, is 20 minus 17. We're getting closer to an answer. So what is 20 minus 17?
3.
3. Corbin, did you get number 15? You missed that while you were out.
I got it.
You got it? Okay.
The biggest numbers.
But remember she said do this work off to the side, which is fine, but then you put a 3 underneath here.
Okay, one more like this.
Circle it.
15 decreased by the product of a number x and 4. So decreased, is it addition, subtraction, multiplication, or division?
Subtraction.
Subtraction. So decreased product. Keyword, what's it tell us to do?
Multiply.
Yeah.
Product means multiply. Okay. So we have 15x and 4. One of these days I'm going to write all over this with my
Oh no.
yeah,
I'll be
dry
back.
erase marker.
There might be race.
We'll see. We'll see. Maybe magic eraser would get rid of that. Okay, so 17 decrease, or I'm sorry, 15 decrease. So 15 comes first. 15 decreased by this, the product of a number x and 4. So we know we need to multiply x and 4. So how do we write x and 4 as multiplication? What do you think? Maya? Well, what always comes first? The coefficient or the variable? a coefficient, so 4x, okay, or 4 dot x.
And if we did that, Maya, you'd have to probably put it in parentheses. You know what I mean? You could do x times 4, but you'd have to put it in parentheses, so you do that first.
So by writing it like this, might just be the better way. I don't have a explanation for that, but, okay, so 15 minus 4x. Now we can go ahead and evaluate by plugging in the value of the x. What's the x? X is equal to 2, right? Okay, so 15 minus 4 times 2. We're going to do the subtraction or the multiplication first? Multiplication. 4 times 2 is 8. 15 minus 8
7.
equals 7. Right.
I think we can get this done, Mrs. Wallace.
I think so too. 18's real quick. Okay. 18. You eat 5 slices of bread. Yum. Your friend eats 2 slices fewer than you eat.
Oh, what is it?
Write an expression that describes the number of slices your friend eats. This is an expression. We don't need to solve it. We just need to write the problem. And it's going to be numerical. There are no variables here because they give us all the information.
Wait, is it okay if we still put the answer?
No, because it would be wrong because they're asking for an expression. If they said an equation, then you would solve it.
Or if they said evaluate the expression, then you'd solve it. But they just want you to write the expression. So how much bread do you eat? 5. And what does fewer mean? Less, which means to subtract. And how many fewer pieces does your friend eat?
2.
2. 5 minus 2. That's it.
Don't solve it.
Yep. 5 minus 2. That's the expression. Okay, number 19.
Come on, Corbin. We're going to finish this. You can
Your
turn it in.
uncle is 2 years older than 3 times your age.
So
2 years older means adding or subtracting if he's older.
addition.
Addition. So we're going to add 3 times your age. You, you better write fast, guys. You are 12 years old. I'm sorry, you are X, I'm going ahead. You are X years old. Write an expression to describe your uncle's age. Okay, your uncle is 3 times your age.
Okay,
What's your age right now?
My uncle's 5.
X. Shh. 3x plus,
You cannot say 5.
plus, how many years more than 3 times your age is he? Okay, your age is X, right?
This 5 goes up here.
Your age is X right now. So your uncle is 3 times your age, so he's 3X. And then it says he is 2 years older than 3 times your age. So 3X plus 2. 3X plus 2.
Write that down.
So that is the equation, or the expression that describes your age. Now in B, we know that you are 12. And some of you in here are 12. Okay? So let's go ahead and substitute the 12 for the value of x. Okay? So 3 times 12 plus 2. What are we doing first, the multiplication or the addition?
Multiplication.
Multiplication. 3 times 12 is 12 plus 12 plus 12.
36.
36
Wait.
plus, he's 2 years more than 3.
38.
Yeah. So 36 plus 2 equals, what's our label? He is how old? 38 years old.
We made it just in time.
Write it out.
You take a picture like
Take a picture,
and submit it.
submit it. It's due by tomorrow. If you want to do that,
Picture during resource.
yeah, we do need to go to special.
What?
Don't lose it, Corbin. Put it in your math folder. Math folder. Good, Hannah. Keep it organized. Take a picture of that today and submit it to me. I'll stick my head in your class at resource time and remind you, okay?
Thank you, Mrs. Wallace.
Thank you.